This next module is entitled Blocks. A block of code is a bunch of statements. It could be zero statements, could be one statement, could be several statements, surrounded by braces or curly brackets. You can see them on the screen. Now what's a statement? Well, if you recall, I earlier mentioned that a statement is simply a piece of code that ends in a semicolon, like a printf or a scanf or an assignment statement. I guess there's an exception to that. A variable declaration is not a statement. It's just a declaration. So a statement is a piece of code that ends in a semicolon that actually does something. Okay, so a block is a collection of those. It could be just one of those, it could be zero of those. Why am I describing blocks to you? Well, you've actually seen blocks before, even though you may not have known them as a block, because every function must contain one block, and main is a function. So every main function that we've ever written contains one block. You've seen the curly bracket at the beginning and at the end of every main. That contains one block of code. And other parts of C, such as the if, the else, the while, the do, and the for statements, they can all either be followed by a block of code or a single statement. Now you haven't seen anything of those except the if statement. You haven't seen the while or the for or any of the others. But take my word for it, when we get to those you'll see that they're exactly the same as the if. So what I'm saying to you now is that after the if, you can put a block of code, or you can put a single statement. It's completely up to you, and the same will apply to all those others. We'll have a look at an example in just a moment. Finally, not quite finally, but blocks can also contain other blocks. You can have a block inside a block. You might just create a block out of the blue. Instead of putting a line of code that says x equals y plus 3, you could put a block of code there instead. Seems a bit of an odd thing to do, put a bunch of curly brackets there when you might not need them, but I'll show you an example of when that might be necessary. And now, finally, variables can be declared at the start of any block. I mentioned before to you that variables can only be declared at the beginning of a function. What I was really trying to say was you can't just declare a variable willy-nilly anywhere within a function. But if you recall, a function contains one block, and if you can declare a variable at the beginning of a block, then you declare a variable at the beginning of the function, which is what we learnt. But I'm going to extend that rule now slightly and say to you that variables can be declared at the start of any block, even if it's within an if statement or within a for loop or anywhere like that, as long as it is at the beginning of a block. That's the only thing you have to remember. You can't declare a variable if a statement has already been issued within a block. Now let's move on and have a look at a piece of code that illustrates all of this information. Here is blocks.c. You'll find it in the chapter 4 folder on your CD. This illustrates the use of blocks. Let's just walk down through the program and have a look at what we've got. There is the beginning of a block. That is a curly bracket or a brace, and you'll find the matching one right down at the bottom of the page, as you might expect. So what we've really got is the name of the function, the round brackets that we are going to talk about a bit later, and then immediately you've got a block. In fact, that's all you've got, and then it's the end of the whole file. So main contains a block, and you'll find that main is just like every other function in that it also contains a block. Now we find that, well, we find a variable declared at the beginning of that block. Okay, good, there's an example of declaring a variable at the beginning of a block. Now we have an if statement. We saw this from the last module. If age is greater than 30, then print out older than 30. Okay, that's pretty straightforward. Now notice that the printf is inside a block. There's the beginning brace and the ending brace. Older than 30. You could put out something like this: age equals age plus 1. I did that to show you that you can have several statements inside a block, not just one. Now I also mentioned just a moment ago that if statements can be followed by a block, or they can also be followed by a single statement. And here is an example of an if statement that's being followed by a single statement. So you've got a choice. You can follow an if statement with a block or with a single statement. Now look at this code. This might look a little bit odd to you. Age equals age plus, let's say 5. I'm just doing any old line of code there. Here's my question to you. If indeed age does happen to be less than 20, which I believe it is in this case because it's actually 15, what will get executed? If you said to me, this printf will get executed, you'd be correct. And if you said to me, this age equals age plus 5 will get executed, that's also correct. But here's the question. If age is greater than 20, now age is not greater than 20, but if it was, what would get executed? Now for all those people thinking that nothing would get executed, you're wrong. This line here would not get executed. This line here would get executed. Now that may really confuse you. Hang on. If age is greater than 20, then this statement, this expression, this Boolean expression is false. And you've said, well, I have said in the past that none of this is going to happen if the expression is false. It will just move on to the next statement. And yes, that is the case. But I want you to reconsider this program now, rewritten slightly, like that. Does that make it any clearer? All I've done is change the amount of whitespace. You see, if statements and compilers know nothing about indentation. They don't care about indentation, they ignore it. They ignore all whitespace. So they don't care if a line is aligned like that or like that. It's exactly the same statement. It certainly makes a difference to us if we're paying attention to the indentation on the page. It's going to confuse us if we see that, because we're going to think that that age equals age plus 5 is somehow connected to the if statement above it. But it's not. It's a completely separate statement. So what will happen is, if age is greater than 20, this statement will get skipped. In other words, the if statement will say that's false, and it won't go inside the if statement, and it'll just move along to the next statement, which is this. If that's what you wanted, if you wanted age equals age plus 5 to happen, then what you would have to do is to do that. You'd have to put an open and close curly bracket around the lot to turn it into a block, because here's the rule. An if statement, and you'll see soon that same applies to for loops and while statements and everything else, an if statement can only be followed by a single thing. Now that thing could be a block, or that thing could be a statement. That's how the compiler treats it. So if you see two things here following the if statement, you can assure yourself that the second of the two is not connected to the if statement at all. Only one thing can be connected to an if statement. I hope that's clear. So let's move on. Printf, a block by itself will follow. In other words, we're talking about a block that is not connected to anything. It's not part of a function. It's not part of the if statement. It just is all by itself, and there it is. There is the opening curly bracket and there's the closing curly bracket, and inside you've got some more stuff. A new variable declaration. Remember I said you can declare a variable anywhere inside any time that you have a block you can declare another variable or collection of variables, but you must do it at the beginning of the block, and that is indeed what has happened here. We have declared a variable at the beginning of this block, and then some code gets executed as well. We assign a value to new age, and then we print it out. Notice that it is quite okay inside this block to reference something that is outside of the block. We're referencing a variable called age, and that's perfectly okay, even though age is not part of this block. It's part of, if you like, the parent block, the block that this block is sitting inside of. I hope that makes sense. We can call this the child block, and the block that it's inside of we can call the parent block. So what happens? Well, we come walking down here and we get to this printf statement, and that executes, and then we just carry on and execute this next line of code, new age equals age plus 30, and then we execute the printf, and then we move on. You may think to yourself, what is the point of having a block all by itself in the middle of the code? Surely it's perfectly okay to get rid of those curly brackets and just leave it like that. It's not connected to an if statement, so surely removing the brackets is just the same as having the brackets there. And you're almost correct. There is very little difference. You'll notice that as it stands now it won't compile because we've got a variable declaration in the middle of a function. So we'd have to take this line of code and move it up to the top of the function if we wanted this program to compile. Other than that, it's fine. So why do we have the block there in the first place? I'll just put the block back again. Why would we have a block like this? Well, one reason is to declare a variable near where you're using the variable. Here we're declaring new age, and here we're using new age, and that's the only time we're using new age. So that's a good enough reason for us to declare a block at that point, is simply to have the ability to declare a variable near where the variable is being used. That's one possibility. Another possibility has to do with memory usage, and it has to do with something called the stack. And we are going to talk about the stack in a later module, so I'll have to leave this explanation until then. So that's about it for blocks. I've shown you that a function is a block. Really, that's all a function is. It's just a big block with a name around it. And that blocks can have blocks inside them, just like this one. And an if statement must be followed by a block, or it must be followed by a single statement, one or the other. You always must follow it with one thing, that thing being a block or a statement. And you'll also see that else's and fors and whiles and do's and even switches are the same. Okay, let's move on.